Hello everybody, how is everyone doing? My name is Leon, I'm a STEM Center tutor. I am also an International Student Ambassador. It is International Ed Week, so I just want to give a shout out to all the international students out there, as well as people from all different backgrounds. We are blessed to live in such a diverse environment, so that's awesome. I just want to make some announcement first from the STEM Center. We are having a water audit here at Kenyatta at this Friday, so if anyone wants to join, please welcome to. And then we are also having a Super Smash Bros. Tournament by the Computer Science Club next Monday from 6 to 9 p.m. apparently. And that's it for the announcement. And here's for the main part. We're gonna have two speakers today, which are Andrea and Annemarie. They're gonna be talking about engineering without water. Please give them a round of applause and I hope you enjoy the speech.
Okay, so good afternoon. Hope everyone's doing well. So we're just going to get started. We'll tell you guys a little bit today about each of our own careers and why we got interested in engineering and STEM before talking a bit about our experience working with the Kenyan team of the Engineers Without Borders chapter in San Francisco, professional chapter. So I don't know how many people in here are already interested in STEM or studying STEM? So a lot of you may already be kind of on the same page with this, or maybe you have other reasons that got you into STEM, but we were kind of told maybe it'd be a good idea to talk about our path that got us there. So for me, engineering has a lot to do with being curious about the world and wanting to have creative opportunities to solve problems using science and math and a variety of tools to break problems down into pieces that are more manageable to solve. And it's also got some good employment opportunities. And in addition, one of the things that was really important to me when I was deciding what I wanted to do was when I realized that there were really opportunities to use engineering as a field for service for other people and also for protecting the natural world and ecosystems. And I know Annemarie mentioned that in her line of work, energy efficiency is really important to her and a big part of what she does. And so we'll kind of get to talk a little bit about all those things today. So for me, my career is in environmental engineering, and I studied environmental and civil engineering in undergrad and did a master's, and then now I'm working in Oakland at a small consulting firm. And it's called EOA, and the big focus of what we do is protecting water resources. Mostly in this area, it's about protecting the San Francisco Bay and local creeks and water bodies. And one of the main focuses we have is on preventing pollution from stormwater. So some of you guys may already be pretty familiar with this, but the storm drain system is there and designed to protect us from flooding. But because the storm drain system just takes all the water and gets it out of the street as fast as possible, it also enables a lot of pollution to get into creeks in the bay because that water goes straight to the water bodies without any treatment. So there's a lot of work involved in keeping streets and our urban environment clean and reducing the amount of water that goes through the storm drain system in order to prevent those pollutants from getting into the bay, into creeks. And so I'll talk to you guys a little bit about that in my next slide, talking about green infrastructure, which is an exciting new part of what's going on in this field. And I also do a lot of work with geographic information systems, and that's an interesting point, I think, for people in STEM because it crosses a lot of different types of STEM fields. It's a really great tool for managing data geographically. And then I'll also mention a little bit about, we also do stream water quality monitoring, and most of what I do, who I work for, we're consultants to our local municipal governments, and that's who we do our work for. So green infrastructure is, I think, a really exciting thing that's going on now because in the natural world, when the rains fall, a lot of that gets absorbed into the ground and gets evaporated afterwards. But in the built environment, as I was saying, there's a lot more hardscape that carries pollutants, and when the stormwater enters the storm drain and goes straight to the bay without treatment, like I said, there's a lot of pollution there. So the green infrastructure approach is really cool because when you, instead of having all of the streets go into this traditional gray infrastructure, go straight through the pipes, if you kind of return parts of the built environment to a natural functioning, to functioning in a more natural way, you can prevent all different types of pollution. So you can prevent PCBs from getting into the bay and mercury and a lot of other things, because when you use pervious pavement, as you can see in that picture up in the corner, if the water flows through and then gets absorbed into the ground, it gets filtered and treated naturally. And there's also similar systems with biotreatment where you have special soil mixes and the roots and the plants are able to treat the water. And so the basic, simple concept is slow it, spread it, and soak it. And that really prevents a lot of things, including also erosion, so that you don't have as much stormwater all coming out at the same time. And I can tell you guys more about that if you're curious. Another big thing we do here is trash pollution. So as you can see, it's a big problem in this area. It's a really populated area. You know, it's a really common thing that a lot of trash gets into the street, and it also then ends up getting into our creeks in the bay. And so prioritizing actions is an important part of what we do in my line of work. And there's different types of engineered systems, like the ones you kind of can see here, that actually capture trash in line in the pipes, or that prevent them from getting into the pipes and the inlets. There's also other types of measures that you can take, like street sweeping or doing online cleanups and public outreach. So we do a big variety of those things. So I get to do a little more than just engineering. And modeling and maps is a really important part of that prioritization. So as I mentioned, I do a lot of work in GIS, so I make maps like these based on data that we've collected in the field. And this helps the city governments prioritize where they want to spend their money, where do they want to install those full capture systems, or where do they want to do the street sweeping. And so when they can see that these green areas are already low trash, they know that they don't have to really worry about that, and they can focus their actions on the areas that are a bigger problem. And so I'll hand this over now to Annemarie to tell you a little about her.
I did mechanical engineering at UC Davis, and once I was done, I didn't want to deal with engineering at all, so I took a 2-year hiatus. Part of it I spent traveling and thinking a lot about what I wanted to do with my engineering degree. And I ended up living in Vancouver for 6 years, and at the beginning of that, I went to a couple talks and I found out about the end of oil and that we needed to conserve energy and so on. So I went and found out what the most impact was going to be, and it wasn't cars, it was buildings. So I got into buildings, and I spent 5 years doing new construction. And in the new construction world, I did a lot of building types, healthcare, high-rise. I did a helicopter facility out in Nova Scotia. I worked on the airport in Fort McMurray, doing all of the plumbing and fire protection there. And we actually had a really interesting system for heating and cooling in that building. And when I came back to California, I had another period of, I need to figure out like where I want to go from here, because new construction was really great. And the buildings were really beautiful, and we had all of these great controls and so on. But I really wanted to learn about existing buildings. And existing buildings are actually the largest consumers of energy, much larger, obviously, than all of this new construction. So I then spent the next 3 years working on energy projects with Siemens and their building controls. About a year ago, I transitioned to another company that does design, and they also do existing buildings. So in their design, they are working in the Salesforce Tower right now. They did the 49ers Stadium, and they worked with Uber and Twitter, the Gap, and we do different projects with them in order to optimize their energy. And actually, I put chiller optimization on the bottom here. Just an interesting story. A couple weeks ago, we had to put a bunch of chillers in the basement. Because if you think about all of these buildings, like they were built in the 60s and 70s, and they have all of this archaic equipment in them, and it has to be changed out. But when they designed the buildings, they didn't really think about that. So there are crazy places that all of this equipment has to be put in. And a chiller can be broken down into different pieces, but a chiller barrel is like, I don't know about that high, and probably as wide as this projector space. And you can't really fit that in an elevator. So what we did with this one project that I did 2 weeks ago is we put it down the elevator shaft. So we brought the elevator up, set up some rigging, and then slowly put the chiller in, and then pulled up the end of it and dropped it down the elevator shaft, and that's how we got it into what we've now termed as the dungeon. So it's been a great career so far, and I look forward to working with more of the buildings in San Francisco. Thank you, Andrea. I also spent time when I was in Vancouver when I did new construction. Does anyone here know about LEED? Or the Living Building Challenge, which is net zero. So the Living Building Challenge and LEED are striving towards net zero everything. And the Living Building Challenge, in order to get the rating that becomes a living building, or that it's rated as a living building, is it has to have net zero water, net zero waste, net zero energy. Like it can't contribute at all to anything in the environment that's wasteful. So this is a small daycare facility, and we had a bunch of mechanical systems in there that dealt with this. And I ended up doing a couple energy models for this, because architects love glass, because they want everybody to be able to see, but I had to talk to them about, okay, you can only have like 30% of the exterior on this building is glass, otherwise you're going to have to make up for it with an enormous mechanical system, and then obviously you can't be efficient with your energy. So it ended up being a really rewarding project because I had the ability to influence the energy efficiency of this building, which was always my goal with my engineering. So Andrea and I are on the Kenya team, and just a bit about Engineers Without Borders. It started in the year 2000 with a very small membership. You can see the numbers. And now that we're in 2016, it's grown like substantially in a 16-year period. And we have, in the Bay Area, the chapter that we are part of has 5 different communities that we're working with. One in Honduras, one in the one we are in Kenya, Nicaragua, Haiti. What's the last one? It's obviously not ours. Yeah. So our team is 15 members. We meet once a month to discuss, what we're doing in design. We get to travel, or the intention is to travel every year. And in that trip, we do an assessment trip, a monitoring trip, or an implementation trip. So when we go out there, we have to look at, what the community needs, and then from that, figure out what kinds of projects we're going to do for that community. And then we go out there and we implement those projects. And then afterwards, we monitor them to make sure that the community understands how to maintain the equipment and understands how to keep them safe.
So I just wanted to also point out a map of the area so you can kind of get an idea of where we're working. So the main points here are this River Munyu down at the bottom, and then the road up at the top, and then the community we're working with is kind of in between those two. And this community was using that river, the water from the river, as well as some springs for all of their needs before we got there. In addition to some wells that were previously installed. They had some wells, but a lot of the people were living not close enough to a well for it to be worth it to them to be able to get all of their daily water. So it was a real issue for them, and they reached out to Engineers Without Borders. One of the big things that Engineers Without Borders as an organization stresses is that it's important for the communities to reach out to us and to communicate their needs so that we're not really coming in and saying, here, this is what I think you need to do. So they reached out to us through an NGO, a guy that was from that community. And then on the first trip, EWB teams will always make a point to talk with the community to really understand what their priorities are. And what they indicated was, of course, wanting to have improved water source. And there were public health issues that were an issue, and they also wanted to ensure, or we wanted to ensure that there'd be long-term independent use, as Annemarie was just saying. And there's also potential for things to go wrong, and so we of course have to be thinking about that as we start a project too, just like with any type of engineering project or other project. And so some of those things in this context are water contamination, stolen materials, and broken water systems. And then we considered all of these and some other criteria.
So our intention for this project was to give the community a better water quality. Because in this moment they were using the river that was contaminated, and we wanted to make sure that they had the water quality that they needed in order to keep their community healthy. And that was a part of the quantity, right? Because they needed to make sure that all of the members of the community were able to have clean water. And the cost of the project, remind me, I think it's 5%. They have to contribute themselves, and then we take care of the rest of it. So in that, we have to do a lot of fundraising for the projects, and we don't do an implementation trip every year. I'm going to ask you again, it's 10,000 or something that we're doing for this drilling. Yeah, so we can get maybe a $5,000 grant every year, but obviously we can't do this every year. So one other thing that we need to consider in the design is the system reliability. We need to make sure that over time they're going to be able to use and maintain this, which is what we used as criteria in order to determine the particular equipment that we were going to use to get that water out of the ground. Can I
Yeah, sure.
for this?
Sure. Yeah, so when we looked at those criteria, one thing that's kind of common in a lot of engineering design considerations is to make a specific system to evaluate your potential options. And so in our case, we used those criteria from the previous slide and then weighted them. So if we thought that the quality of the water was the most important thing, then that would have the highest weight. And then we looked at a lot of different alternative solutions. So some of these included a hand pump, which was something that was already present in the community, as well as some mechanical pumps, so that would be powered by, as you can see, either solar electricity or gas engine. And then we considered adding on a distribution system, which would be like piping the water to different houses and buildings in the community. And we considered other options like treating the water with chlorine, or building a sand filter by the river, or getting water catchment from rooftops. And a lot of these are used in different communities in different parts of the world. And this is another thing that's important to Engineers Without Borders, is to really get to know each community and to try to make sure that you're choosing the solution that's going to be the most effective for them, because every community is different. And so we did our best to work with them to understand which of these solutions would be a problem for those potential sources of potential problems and challenges that we had in the previous slide. With broken materials was one. So that was something that they brought up about the mechanical pumps and the distribution systems, that they felt that if there was a solar generator, that might get stolen So, it's something valuable in their community, so that's one of the important reasons we try to really keep them involved in the design process. And then we looked at these, and one of the other points that really helped the winner win was that it was already being used in the community, so that sense that it would be a reliable solution that would be really well received and adopted by everyone there was definitely part of that choice. So that's what we ended up choosing, was a hand pump, which is what you see in the picture up top. And then another important part of the design was locating the borehole. So as I mentioned before, it's kind of, if you can recognize, there's still the same road up there and there's the river down here. And so these black circles are where people were already being serviced. So there was a well in this location and up there in that location. And I think some of the other wells were existing but maybe not fully functional. And all the little yellow dots are structures, so those are the houses. And there's obviously a big area where people were living closer to the river than to any other water source. And so that was chosen, based on specific analysis here, as the best location to serve the most people. But in addition to just choosing the location based on demand, we also had to consider the hydrogeology, so the groundwater situation at that location, as well as getting to know all the information we would need for permits, like making sure it would be okay with the landowner, and there's a lot of overhead work that's involved with this. So we did hydrogeological testing, and that's someone from Kenya performing these tests, and figured out the exact location for the drilling. And okay. And so then we next had to send out a request for drillers to submit their cost estimates to us. So as you can see, not every single driller is really up to the expectations you might have in the US. And so there's concern about whether they'd be reliable, and our team and a lot of other teams in Engineers Without Borders from other parts of the US have had some issues with delays because, every culture is different and not every culture has the same expectations of what it means to be on time to something. And so that, for me, is one thing that I really admire about this team. Before I had even joined, they had learned from their first experience, the first time they went to drill a well, that was an issue. And so now when we travel, we send teams of 2 in a staggered 2-week period, so that we have our team presence for a month and a half, and that way we can kind of work with the culture, and if there's delays, then it works out, and if there's not, then we just have more time afterwards to engage with everyone in the community and do some monitoring. So this is an important part of the process, and getting to know the driller and making sure that they have the materials and the experience to do the job correctly. And there's more to the story. There's some really great, I didn't know how much time we'd have, but there's also some really great parts about the driller trying to get from location A to location B to actually do the drilling. As you can imagine, there's always a lot of challenges when working in a place that's, that you don't know as well as other people, so we work really closely with them. There was a great story about one of the older guys in the community coming out and saying, "Why are you trying to get it all the way through this road where you're clearly never going to make it? It's too muddy. Let's just chop down some of these trees and get you straight through here." And so they did it, and they got the well drilled. So that was the first well, and then a couple years ago they drilled a second well at a clinic location, and both of those wells are successful. There was a third well that they tried to install at the same time as the clinic well on that same trip. But that well, unfortunately, didn't produce water, so the hydrogeological testing wasn't enough. You can't always know everything. You're drilling pretty far deep. It's about 200 feet, I believe, that they drill. And so it unfortunately didn't produce water, that one at the school. But there's good news that there's another water project going on nearby now. So hopefully that school is also going to get water from a government source. And it's really wonderful getting to see the positive feedback from the community. And obviously not everything always works out the first time around, but we've kind of been working with this community now for more than since maybe 2006, it'd been at least 6 years, 2006 or 2008 or so. And so we've got really good connections to the people that we work with there, and there's always more that we can be doing though. So we always make sure to take time to go back and monitor what we've been doing and make sure that it's still working. One example of, I'll give a positive and negative example from this clinic well that was installed 2 years ago. So when I went on this trip in November, and when I was here, we met with some of the women that live near the clinic and that use the clinic well. And on the one hand, they were all saying, like, we're so happy that this is here and we're really using it and it's really great for us. But on the other hand, they said, it's not really enough time for us to get all the water that we need. And they said, because this is on a clinic property, the clinic says that, you know, there's a lot of important privacy for the people who are at the clinic, and so they don't want everybody just coming on their property all day to get water. So in order to solve this problem, we said, well, guys, let's just build a fence that, you know, cuts around so that you can go, so you can cut in to get to the well without going on to the clinic property. And so that was a solution that they were happy with, and an important part of doing that monitoring to follow up and make sure you're really being effective. But another really exciting thing about, did you want to do? No, did you want to?
So one of the exciting things that we found out in April of 2015, which was slightly before Andrea went out to Kenya to do monitoring, which went for her November trip, we had in the area, there were 600 cases, like in the larger area, we have a smaller community within that area, there were 600 cases of cholera that were reported in the area. And in our community, there were 0 cases, which, you know, from the perspective of what we've been doing in the community, the fact that none of the people that we've helped with this well got sick was just, it was really rewarding. So, from here, we have monitoring that's ongoing. You know, we have a team that's going out in January. There are 6 people, and as Andrea said, there's a staggered, they're going staggered, so, you know, 2 weeks and then a couple days overlap and then 2 weeks and then 2 weeks, just to make sure that we have ample time to do monitoring in the community that we already have a well in, and then for time to do the implementation in the other community. And as Andrea also mentioned, the drillers have sometimes difficulty in this part of the world being on time or showing up at all. So we have to make sure that they're going to be there and that we're able to put this water system in place.
Yeah, so I guess since we have enough time still, I'll just talk a little bit about this new community that we're going to be working with. So that kind of took you all the way through implementation from the very beginning to the end of a project. But as we were finishing those 2 drilling trips 2 years ago, we were starting to wonder what our next thing was going to be that we were going to do. And we heard from the neighboring community, this community where there were 34 cases. During that cholera outbreak of 600, they had 34, and then right next door neighboring community to Arombe, and they said there were an estimated 4 unconfirmed deaths and 1 confirmed death from that outbreak. And so that community got really motivated, and they want to partner with us to drill a well. And so they talked to the people in their neighboring communities, some overlap of people, their communities are so close together, there's a lot of overlap. And they said, yeah, it's walking distance. They're right on, they border each other directly. And so they submitted an application, and then we helped them submit that application to EWB USA. And they said, we want to work with Engineers Without Borders to drill a well near our school, and we want to do it quickly. And so we worked with them, and they were really motivated. They said, yeah, we can do that 5% contribution, no problem. And that 5% also goes along with that same desire for these projects to be sustainable, it's really important for communities to be invested in the solution. And so if we make sure that they have to contribute somewhat financially or through their labor or a combination of both, then that lets us know that they really are on board and that we're not just coming in and doing something that we think is right. They are saying, yes, we're putting up our resources to help make this happen too, and we're really invested in it. Yeah.
So we're working with the community that we've been working with for the 6 years. We now have this community, and I just wanted to add that there's another community in the area that Oregon State was working with, and there are now travel restrictions for Kenya, and they're no longer able to help that community. And we had a discussion on our team, and because the community is so nearby with the two communities that we're already working with, we volunteered to go out and assess the 3 wells that they already have. And they were promised 6, so when we go out there, we're going to spend time monitoring the ones and seeing how the ones that are already there are contributing to the community, and whether or not that satisfies the need that they have, and or whether or not they would need to have either Engineers Without Borders USA come in with another team to help out with that, or whether possibly we would be able to take that on as a team. And part of taking it on as a team is there's a huge fundraising effort, obviously, that goes into each one of these projects. So it's a big responsibility for one team of 15 members to, do all of that fundraising, because as we've seen our friends get kind of exhausted with, hey, come out and support us a little more. So so we'll have to make that decision once the team gets back at the end of January and find out how we can help that community or what they need, and whether or not we have to support them in the interim until Engineers Without Borders USA gets a chance to send another team out there to take care of that community too. So I think we have time now for any questions that you have about Engineers Without Borders, about my background, about Andrea's background, and we're here as, I guess, resources for you in this moment to share, what we've learned, what we've been through in our own careers. So, go ahead.
How often do you guys partner with other international organizations?
So typically for Engineers Without Borders, our team is a little not typical, but the typical arrangement is that you have a community, a local NGO partner, non-government organization, nonprofit, and then the Engineers Without Borders chapter or team from the U.S. In our case, the community in Arrombe Bay first reached out to us through a small local nonprofit, which was mostly a guy, and that guy went kind of MIA within the first couple of years, and that's part of what slowed the project down a lot early on, and took him a little while to get that first well designed and drilled. And part of what's made it smoother for us moving forward is that we're really working just directly with the community. But even so, we still try to keep that some element of that nonprofit organization partner. In the previous year, we were drilling at a school and a well. A school and a clinic as well. And the clinic was functioning as our nonprofit partner. And now we're working with that community where it's the school that submitted the application. So the school teachers are kind of both the community leaders and the nonprofit organization that's organizing with us. But in a lot of other situations, for a lot of other teams, they will be working with other international nonprofit partners that are locally based that can kind of help them with the communication throughout the year and with monitoring, and that can often be a big help. I don't remember if there's something else about that, but yeah, hopefully that. Oh, I remember the other thing I wanted to mention about that. Another thing I'm not surprised I didn't mention during this presentation was that another important part of having sustainability and reliability for your project over time is to make sure that there's organization within the community around the project. So the first well that got drilled, they formed a water board with community leaders, and so there's like a treasurer who collects money and fees from the people, with small fees, which is more affordable than, for example, using chlorine on a regular basis, which is what some of them are currently doing in Masara, for example. But by paying small fees, they can save up money so that if the system breaks or needs maintenance or repairs, they can afford that. And that's another really important part of setting a successful project. So as you can see, while engineering is definitely really important, it's not just engineers that are important to this team. And so we actually welcome engineers and non-engineers of all backgrounds to help in our projects. But yeah, that's it.
Especially event coordinators, so if any of you have done a wedding or a party or whatever, please join us and help us raise money for these projects. So, does anyone else have a question that we can answer? Okay.
Did you have any
Advice, oh boy. Advice for what would you recommend?
I just remember we were recommended to give some advice to aspiring STEM students, and mine would be to learn a technical skill. So I know the whole field is technical already, but in my case, that's the GIS. It's really, really helpful for having that on your resume when you get out of school, to have something specific like AutoCAD or GIS, and to have, or if it's in a different field, if you learn R, learn to program something basic like Python, because that's really how a lot of things are done now. And of course, the theory is incredibly important. But if I had to give some advice to somebody who's an aspiring STEM student, I'd say make sure you have the technical kind of tools and that you can use.
Okay, so advice, you said AutoCAD. So when I went to Davis, they had a program called Ideas, and it was a bunch of like 3D modeling. I got to make a gyroscope from it, like design and then build a gyroscope in the machine shop, which was very cool. But with Ideas, I never learned AutoCAD. So when I got into my first job, I had to learn AutoCAD on my first deadline. So what my senior did for me was say, okay, this is copy and this is paste, go for it. And I ended up, learning a lot about AutoCAD just on the job. And I think I would say, and I think partly my father's influence about problem solving, once you've done engineering, once you've done mathematics, once you've done science, you can learn so many things if you want to go into another profession after that, because you've figured out, how to break down, as Andrea said at the beginning, how to break problems into pieces that are more solvable. Anything that you end up wanting to do after you've done an engineering, science, math, technical career, you really have the tools to be able to do that well. Anyone else with questions? Okay.